Okay, hello everybody. A couple students asked me to provide a key to the practice exam so that you guys could check your answers. So this video, I'm going to do the first 4 questions and then I'll make another video with the last few questions so that you guys can check your work. So this first question asks us to sketch the graph of some different functions. They're all linear functions, and they tell us whether or not the slope and y-intercept are positive, negative, or 0 in some other cases. So let's start with the first one. We know that the slope of our function should be positive because of this m greater than 0, and we know that the y-intercept, or the vertical intercept, should also be greater than 0. So if I were to draw it on a graph, it might look something like this. Okay? The reason that this graph matches this information is m greater than 0 means that my slope is positive, which means that I should be going up. As I move from left to right, I should be going up. It's an increasing function. The fact that b is larger than 0 tells me that my y-intercept, or my vertical intercept, which is here in pink, that doesn't show up very well, why don't I do it in green? Here in green, since it's larger than 0, it should be above the x-axis. Okay, so I'm going to go through these next ones fairly quickly. This time we're going to have the same deal with the y-intercept, except our function's now going to be decreasing. So maybe it looks something like this. That could be a line satisfying those two properties. Next up, we have an increasing function with a vertical intercept which is less than 0, okay? So the slope of my function is going to look something like the first one, except the difference here is that my vertical intercept is less than 0, so the place where it crosses this axis here, this y-axis, should be below the origin. So it might look something like that. Now we have a decreasing function, which also has a vertical intercept which is beneath the origin. So decreasing and beneath the origin, maybe it'll look like this. Okay, and next one. This one we got to get a little bit tricky. We know that m is equal to 0. Now remember, m is my slope, which represents rise over run. If I have a fraction, rise over run, and it's equal to 0, that means that the numerator, in other words, the rise, should be 0. So if I run for 1 unit, the amount which I rise, or go up and down, is 0, which means that I'm moving to the left and to the right, but I'm not moving up and down at all. So m equals 0 corresponds to a horizontal line. The fact that b is larger than 0 tells me that this line should lie above the x-axis. So what would it look like? Looks something like this. Okay, and lastly we have a line with negative slope and a y-intercept of 0. If the vertical intercept is 0, that means that this line is passing through the origin. So I should have a line which is decreasing since my slope is negative, and it should pass through the origin. So maybe it looks like that. Okay, so these are all the examples for this problem about really how to draw linear graphs depending on the sign of the slope and the vertical intercept. Okay, question number 2. I like this problem. It's a word problem. So Kyle reads the following problem on his homework assignment. He's supposed to determine whether the following table of inputs and outputs represents a linear function or not. And he's also supposed to find out whether or not this function is increasing or decreasing. So the answer that Kyle puts on his homework is this thing highlighted here. He says that it is linear because each time it goes up by 2. Since it goes up each time, the function is increasing, and we're supposed to evaluate whether or not Kyle did a good job on this problem. Okay? So the first thing that I want to point out is this reasoning is already a little bit suspect. Each time it goes up by 2 is not a very specific statement. Okay, I think we can do better than that. So let's take a look. From here to here, our x went down 3, so we had negative 3 on the bottom. That was our run, and our rise was 2. Next step. I should move this a little bit. Oops, don't want to grab that. Why don't we just grab that? Nope. Man, come on. All right, so that was the first one. Second step, down 3 again. And we went up 2. Third step, looks like we went down 4 this time. And we went up 2. And the last step, we went down 3 for the x's, and we went up 2 for the y's. Now remember, if I'm going to say that this is a linear function, then the change between these intervals should all be the same, or should all be proportional to one another. Okay, so I could have had maybe another one here that was like 4 over negative 6, and that would be okay if I had some other thing like 4 over negative 6. This is fine. However, there's something that's very not fine about all of these equal signs, namely this one right here is not true. Neither is this one, right? Negative 2/4 is not equal to negative 2/3, so we can conclude that Kyle's already, oh man, zoom out, come on. Kyle is already wrong just on the basis that he said this function is linear. Okay, so the first step of my problem, I would write, I don't agree with Kyle that the function is linear. The slope between x equals negative 3 and x equals 7 is different from all the others. Okay, so that's my first statement. Now let's deal with the second part. It says, since it goes up each time, the function is increasing. And this is kind of a naive way of thinking about this problem, and a lot of students fall into this trap because they see the y values, aha, it goes up, and then up, and then up, and then up. I see the y values going up, that means I must be increasing. But we have to also consider what's happening with the x values. Yes, my y values are going up, but my x values here are going down. We need both of them going up at the same time in order for this to be increasing. So the way that I should always read these is from left to right. If I think about my x values being plotted from left to right, -10 is going to be the leftmost point. So at -10, my y value is 13, and then I move to the right, I hit -7, and my y value actually went down. And then I keep moving to the right, and I see that my y value is decreasing each time. Okay, so the direction that we should really be thinking of is this upwards direction, which is the other thing that got Kyle tripped up. So the next part is I also disagree that the function is increasing. Period. Each time that x increases, the y value decreases. Therefore, the function is decreasing. Okay? All right. So let's see. Do you agree with Kyle? If so, find a formula. Okay, well, we didn't agree with Kyle, so we didn't wind up having to do this part of the problem, finding the formula. Hopefully, if somebody did agree with Kyle, they realize once they start this part that it can't be done. Okay, next problem. All right, in December of 2019, John drank on average 5 beers per week. By April of 2020, John was consuming 8 additional beers per week, and by August 2020, John was downing a hefty 21 beers per week. Okay, before I even start this problem, I'm going to go ahead and put this information into a table. They tell me that A of T measures the amount of beers per week that John is drinking in the Tth month. Okay, so I'm going to make a table here with T and A of T. And let's see here. We'll have some data points in here. Okay, and half of this problem is really just figuring out how we should fill this in. Now, remember, we always think of our starting time as being t equals 0. Our starting time in this problem is December 2019, okay? So, at time t equals 0, John drank on average 5 beers per week. So I'm going to put a 5 in here. Now, I have to be a little bit careful thinking about what t values are April 2020 and August 2020 going to represent. So if we've got December, January, February, March, April, and December is t equals 0, then January is going to correspond to t equals 1, February is t equals 2, March is t equals 3, and April is t equals 4. So in April of 2020, John was consuming 8 additional beers per week. So t equals 4. If I started drinking 5 beers per week and then later on I'm drinking 8 additional beers per week, then the amount of beers per week that John is drinking in this month will be 5 plus 8, which is 13. Okay, so that's how I got that into the table. Okay, next up, August 2020. I'm going to keep following this thing on the left here. Okay, so we'll have May, June, July, and then August. So 5, 6, 7, and 8. So at time t equals 8. Now it doesn't say how much we increased by this time. It tells us the amount during this month is 21. Okay, so now we've got all of our information into a table. I think this is a good idea just to keep all of this information straight because it's kind of all twisted and tangled up in this word problem. Okay, so we're supposed to answer the following questions. The first one, is John's habit advancing linearly or exponentially? Well, let's go ahead and take a look. If this is going to be advancing linearly, we should expect to be able to do the same thing that we did with the previous problem. So, from here to here, our increase in our dependent variable, which is a, was 8. So our rise was 8, and our run was 4 months. Next step, 21 minus 13. Our rise was 8, and again, our run was 4 months. Okay, these two numbers are equal, so I feel confident saying John's habit is advancing linearly since the rate of change is constant. By constant, I mean it's consistent throughout. The first time I went up by a factor of 2, and the second time my slope was again 2. Okay, so that's already a hint for the next problem, where we're going to have to actually find a formula for a of t in the form which we specified in part A. So we know that it's a linear function. The form I should be looking for should be a of t equals mt plus b. Okay, mt plus b. Now I think that my m here, my slope, is going to correspond to the rate of change between each of these two data points. Okay, is going to exactly be these numbers here. This is my rise over my run. So I know that m should be 2. I got that information from the table. So I have a of t equals 2t plus b. And if you're quick, you could just use your intuition to recognize what b should be, but we can go the long route and go ahead and try to take one of these points here, and we're just going to plug it in and see what we get. So I'm going to plug in 0 for t. So 2 times 0 plus b, and that's going to be equal to a of t. Well, when t is 0, a of t should be 5. So I get b equals 5. So this is telling me that my formula should be a of t equals 2t plus 5. Okay. So that's how I figured out the equation for this problem. All right, next they ask us if John halved the rate at which his drinking increased when he started in December, in which month and year would John drink 22 beers per week? Carefully show your work. Okay, so the first thing I need to take from this word problem is halved the rate at which we're increasing. This reads as divide the slope by 2. That's what this is telling us to do. So I'm going to have a new formula, b of t, we'll call it. So this is the alternative path that John could have taken. And it's going to be equal to the same, except the only thing that's going to change is my slope is going to be half of what it was before. So now it's just going to be t plus 5. That is my new formula. And the question they ask us is, in which month and year would John drink 22 beers per week on average? Okay, so what we really want to say is that this thing should be 22. So we want to solve 22 equals t plus 5 and then interpret our answer. Well, I can just move 5 over to the other side and I get t equals 17. And now I need to interpret which month and year corresponds to t equals 17. Okay, so I know that December 2019 is t equals 0. Let me zoom in over here. I know that January 2020, that's t equals 1. And then if I were to keep going, I would find that December 2020, that's going to correspond to t equals 12. And then I'll have January 2021, that's going to be t equals 13. And then I need to go 14, 15, 16, and 17. Well, I think it should go February, March, April, May. So the answer is John would consume 22 beers per week in May 2021 using this model. And that's how we would answer that question. Okay, question number 4 is asking us about an average rate of change problem. So they want us to write down the formula for the average rate of change of f of x on the interval a comma b. Explain in detail what the numerator and the denominator represent in terms of the graph of f of x. Okay, let me draw the graph of f of x, and let me remind you what the average rate of change represents. Don't want to use that. We'll use this. So if here's my a and here's b, now I want to know the average rate of change of my function on this interval from a to b. First of all, a to b is the interval here in purple. This is what we would call a comma b. Okay, a comma b consists of all of the points in between these two endpoints, including the endpoints themselves. Okay, so that's a comma b. And the average rate of change, remember, gives us the slope of the direct path here. Okay? If I wanted to find the slope of the line which goes through the points a comma f of a and b comma f of b, I would do rise over run. So I would say average rate of change equals f of b minus f of a, all divided by b minus a. And the way I would answer the second part of the problem, explaining what the numerator and the denominator represent, is as follows. I would say the numerator represents the net change in height of the function f of x between x equals a and x equals b. Okay, so what I'm talking about here is this distance right here. Okay, the difference in height between these 2 points. Okay, now let's talk denominator. The denominator represents the horizontal distance between x equals a and x equals b. So in orange, we're talking about this distance right here. Okay, so this distance between our 2 points horizontally. Okay, so that's what's going on with our denominator, and our numerator is representing the change in height. So in other words, it's rise over run. Okay, so the next problem asks us, if the average rate of change of g of x on 1 comma a was 10, g of a is equal to 20, and 1 comma 4 is a point on the graph of g of x. We're supposed to figure out what a is. Okay, so one thing that you shouldn't let trip you up is the fact that in this problem, presumably in an attempt to confuse us, they put a on the right-hand side of our interval, whereas the usual way we're used to seeing it is with b on the right-hand side of our interval. Okay? So, all that this means is when I see this interval here, I'm going to put the right endpoint in to my formula, wherever my formula says to put the right endpoint of a comma b into. So let's write it out. We know that the average rate of change should be equal to g of our right endpoint, happens to be a this time, minus g of our left endpoint, which is 1, all divided by a minus 1. Okay, our right endpoint less our left endpoint. Okay, and so we've been given some information in this problem, and we're supposed to figure out what a is. The first thing I see is g of a is equal to 20. Okay, so where I see g of a, I'm going to put 20. The other piece of information I'm given is 1 comma 4 is a point on the graph. If 1 comma 4 is a point on the graph, this tells us that g of 1 equals 4. So this red information, which we got from the problem, is telling us what to put in for g of 1. The last thing they tell us, running out of highlighter colors, is the average rate of change itself. They told us that we got 10 when we did this process. So 10 is going to go on this left-hand side here. And then we're just going to have to solve for a algebraically. So we got 10 equals 20 minus 4 divided by a minus 1. I want to get a by itself. Right now it's in the denominator. So I'm going to try to get rid of the denominator on the right-hand side. The way I get rid of a denominator is by multiplying by it. So I'm going to multiply by a minus 1 on the right side. I know if I do that on the right side, I should do the same thing on the left side. Okay, so we cancel here. And we wind up with a minus 10 equals 20 minus 4. In other words, a equals 16 plus... What am I doing here? 10a. This should be 10a minus 10. And then this should be 10a equals 16 plus 10. So a equals 26 divided by 10 equals 2.6. Okay, let me just check my work here and make sure I did that right. Got multiply by a minus 1, we cancel. This becomes a 16 on this side. On the left-hand side, we get 10a minus 10. Add 10 over. Divide everything by 10. Yep. Feel confident that this is the right answer. So, the problem tried to trick us in a couple of ways. First, they gave us all of this information in kind of a wacky order. And secondly, they asked us to find something which is sort of non-standard. Usually they ask us, find the average rate of change on this interval. This time they told us the average rate of change and they wanted us to find out what one of the endpoints was. Okay, so it takes a little bit of a greater understanding of how this formula should be arranged. After that, once we got to this step, it was just algebra of canceling things out and isolating one variable. Alright, that's it for this video. I'll do the next few problems in the next video.